Hello everyone, and welcome to 30 Days of Java. It's day 26 now, and today we'll discuss multi-threading in Java. In this video, we'll start by exploring the concept of a thread, then we'll delve into the topic of multi-threading and its various implementations. So let's get started. Let's understand the concept of a thread with a real-world example. Imagine you're a chef at a restaurant, and you might have different tasks like chopping vegetables, boiling water, and frying meat. Each of these tasks can be thought of as a thread. They all work together to complete the meal, which is the process. Similarly, in Java, an application is made up of various processes, which in turn contains one or more threads in them, which perform a specific function. So a thread represents a separate path of execution within a program. Now that we understand what threads are, let's discuss multi-threading. Multi-threading in Java refers to the ability of a Java program to execute multiple threads concurrently. This concurrency enables a program to perform multiple tasks simultaneously, improving efficiency and responsiveness. A real-world example of multi-threading is akin to driving a car while listening to music. In this scenario, you are simultaneously performing two tasks, navigating the vehicle and enjoying your favorite tunes. This dual activity mirrors the concept of multi-threading in programming. Now there are two approaches through which you can implement multi-threading in your program. You can either extend the thread class or implement the runnable interface. Now let's jump on to IntelliJ to implement them. So here we are in IntelliJ. Now let's first create a class here. So we'll go to src new and then Java class, and we'll name this class as counter. Now the first approach to implement multi-threading in Java is to extend the thread class. So I can simply write extends and then thread here. Now this counter class would have a data field called int thread id, and we'll also create a constructor public counter. Now this constructor would set the value of this thread id. So I can type in int thread id, this dot thread id, and now we'll override a method from thread class. So we'll type in public void and then run. Now to denote that this method is being overridden, we can write override. Now this run method would contain the logic that the thread would execute. So here we'll simply create a for loop that would print out the values from 1 to 5. So I can type in for int I equals to 1, I smaller than equal to 5, I plus plus. And I can type in I plus from thread and then thread id. Now we'll also need to add delay here, because if I run this program as it is, it would print out all of those values in an instant and you won't be able to see the multi-threading in action. So I'll give it a delay of 1 second by typing in thread dot sleep, and then I'll give it a value of 1000 milliseconds, which is equivalent to 1 second. Now this method sleeps the current thread for a certain amount of time. Now we are getting an error from compiler. If I hover over it, it says surround with try catch block. So I can remove this. And that's it. We are ready to use this class now. So if I go back to my first program.java and create an object of that class by typing in counter, my count equals to new counter, and then give it a value of 1 as thread id. Now if I run this by typing myCount.start, so we are using start method here because it creates a new thread and then executes the run method that we have just written. So if I run this program now, you can see we are getting back the outputs from 1 to 5 at a 1 second delay between them. Now we can also create another thread here by copying this object and creating a new object named myCount2, and we'll give it a value of 2 as thread ID. Now I can type in myCount2.start. And now if I run this program, you can see we are getting back the values from 1 to 5 from both thread 1 and thread 2 respectively at a 1 second delay. Now if I were to use the run method directly instead of using the start method, so I can type in run here and also type in run here and then run this program, you can see it first executes all the logic for thread 1 and then shifts its focus to thread 2. Now this is happening because when you use the run method directly, it doesn't create a new thread. It executes the whole logic in a single thread. But when you use the start method, it creates a new thread. So always remember, start method creates a new thread and then executes the run logic. But run doesn't create a new thread. Now one more thing to remember here is that the compiler doesn't wait for these threads to get completed before moving on with the program. So if I were to write sout program ended here and then run this program, you can see it printed out program ended at the very first. Now why is this happening? So when the compiler reaches line number 6, it creates a thread that handles the myCount object. Then it reaches the line number 7, which again creates another thread for myCount2 object. And then it simply goes to line number 9. So the threads created in line number 6 and 7 run independently from the main thread that we are currently working on. That is why we see the program ended before we see everything else. But now suppose if I want to wait for those threads to get completed and then print out program ended, so I can simply use another method here called myCount.join. Now this method blocks the execution of the main thread until the myCount thread is completed. So I can also write myCount2.join here to also block that thread's execution. Now we are again getting an compile time error, so I can simply add this throw interrupted execution to resolve that. Now if I run this program, you can see it's first printing out all the logic from thread 1 and thread 2, and then it printed out program ended. Now you might be wondering what is the advantage of using multi-threaded program in Java. So to demonstrate that, we'll create a counter here which will calculate the time taken to execute this logic of program. So I'll go here and create a long variable named start time, and its value would be system.nanotime. Now system.nanotime returns the current time in nanoseconds. Then we'll copy this and also create another variable here called endTime. Now to calculate the time taken, we can simply type in long time taken equal to end time minus start time. And to convert this into milliseconds, we can write double time taken in milliseconds equal to time taken divided by 1 million. Now I can use this variable here, program ended in time taken in milliseconds. Now if I run this program, you can see it took 5060 milliseconds to complete this program. But if I remove this multi-threading here, I'll comment this out, and instead of using the start method, I'll use the run method. And now if I run this program, you can see this time it took 10,089 milliseconds, which is approximately double of what we had with multi-threading. So this is the power of multi-threading. It makes your program more efficient and faster. Now let's change this back to start. Now let's clear this program a bit. So I'll remove this part and also remove this. Now another thing that I would like to point out here is that the threads that are running in a multi-threaded environment doesn't always run in a sequential manner. So to understand that, I'll remove this thread. Now instead of creating multiple threads manually, I'll create a for loop here for int I equals to 1, I smaller than equal to 3, I plus plus. And here I'll copy paste this part. And instead of sending the thread ID as 1, I'll send it as I. Now suppose if I run this program now, you can see that we are not getting the output back in a sequential manner. With sequential, I meant that the thread 1 was created first, and then thread 2, and then thread 3. But if you look at the output here, we are getting 5 from thread 3 back before thread 1 and thread 2. So always remember, in a multi-threaded program, the threads might execute in an order that is different from the order in which they were created. Now, as I mentioned before that there are two approaches to implementing multi-threading in Java, let's look at the second approach now. So if I go back to my counter class, and the second approach through which I can implement multi-threading in Java is to implement the runnable interface. So instead of extending, I'll write implements and then runnable interface. And that's it. We don't need to change anything here in the counter class. But if I go back to my first program, you can see I'm getting back a compile time error. So to use the runnable interface, I need to add another line here. So I need to add here thread, my thread equals to new thread, and then inside the constructor, I'll pass in my count object. Instead of using my count object here, I'll type in my thread. And that's it. If I run this program now, you can see it works without any issue, just like before. Now the main difference between using a runnable interface or thread class lies in inheritance. As you already know, Java doesn't support multiple inheritance. So if I extend thread class in my counter class, I can't extend any other class. But I can implement multiple interfaces. So even if I have runnable interface, I can implement another interface by simply typing in runnable and then pass in any other interface here. And it works without any issues. Let's remove this now. So this is how you can use multi-threading in your Java program. Now multi-threading gives you a lot of power, but as you already know that with great power comes great responsibilities. If you don't write these multi-threaded programs carefully, you might fall into issues like deadlock or race around conditions. Now problems like deadlock and race around conditions are outside the scope of this course. But if you want a video on that, you can let me know in the comment section below. As always, we'll end this video with a quote that says, "What is to give light must endure burning." Thank you for watching and have a great day.